Hello IBSL2. This topic is quadratics completing the square leading to vertex form. And want you to first to look at some formulas that we have in our formula pocket for functions and equations. So topic 2, it does give you the axis of symmetry of a graph of quadratic function. So if you see that word come up, or if you need to find the axis of symmetry of the parabola, remember, you can find your vertex using the axis of symmetry of your parabola. So this formula. Also, in topic 2, they show the relationship between log and exponential. And the third part in topic 2 is giving you the solutions of the quadratic equation, so using the quadratic formula, and the discriminant. Tonight, this video is not going to be talking about these two formulas. We're mostly talking about the axis symmetry, but I wanted you to see what formulas are available to you. Okay, so first we're just going to jump right into an IB problem that you might see. And this one is a 6-mark question, and it has 3 parts to it. The first part, it wants you to express the function f of x in the form of f of x equals 2 times x minus h squared plus k. Now, it's been a few years since Algebra 2, so remember this is our vertex form. H and k is our hk is our vertex. So if you start with our first function and we want to get it into vertex form, then we'll need to complete the square. So for first step is to realize that there is a stretch factor of 2. Every part of our equation here is multiplied by 2. So our first step for f of x is factoring out that what we called, or the stretch factor of 2. So let's just first write down our equation. And then that's a minus 6. And to realize that when you're completing the square, when you do complete the square, you have to factor out the x squared has to be by itself anyway. So if we just factor out that 2 from only our x squared and x terms, that will help us just realize what we're going to do to complete the square. Okay, there was 2 ways to think about completing the square, and I know my Algebra 2 students, some of them like to think about it globally, other people like to use the formula to help them. So first, if you're a global learner, you're thinking about what are you going to put here to make this a perfect square. So what times what would be end up multiplying out to x squared plus 2x plus something. And so you know that you're going to have to make a perfect square here, and the only thing that would be the same thing multiply itself to add up to 2 would be x plus 1 times x plus 1. That would be the perfect square that you would create. Okay, so here you can see that we would add a 1. Some students really have trouble thinking about it globally, so we always also learned to take the b value, divide by 2, and then square it. So b divided by 2 and then squared. So either way, we're going to get 1 in this case. So 2 divided by 2 is 1, and 1 squared is 1. So we're going to be adding 1 to the inside parentheses to complete the square, and then we have to realize that we actually have to subtract 2 because we can't change the equation. So this 1 is being multiplied by 2, so we'll have to subtract 2 when we go to add the 1 inside the parentheses. So now we have a perfect square here. It's x plus 1 times x plus 1 minus 8. So we can create our vertex form of 2 times x plus 1 squared minus 8. And so our h, our vertex, x value of our h is negative 1, because remember our equation is written as x minus h squared. So our vertex for this parabola would be negative 1, negative 8, and there'd be a stretch factor of 2. The second way to find this part A would be use your axis of symmetry formula. X equals negative b over 2a. That finds your h value of the vertex, and then you can plug in your h into your original equation to find the y value of your vertex. So that would be the second way if you don't remember or think you're going to have trouble remembering how to do completing the square. So 2 ways to do part A. Part B, they want us to find the equation of the axis of symmetry of the graph. So once you found your h, you can remember that you're going to do the negative h when you pull it out, the opposite sign of whatever is you found. So our equation would be x equals negative 1, and if you want to check your work, x equals negative b over 2a, you could find your axis of symmetry plugging in, and b is 4, so negative 4 over 2 times a, in this case it's 2, and that would be negative 4 over 4, which would be negative 1. So our equation, we know we found it 2 ways, is x equals negative 1. For part C, they want us to find, express the function in the form of 2 times x minus p times x minus q. So here it has it in the solutions. You can solve for our solutions. There's several different ways to think about that. Using the quadratic formula, we can solve again using completing the square. And since we already did talk about completing the square, let's use that to solve for x. So here's our function, and we have our y. Our function is written as 2 times x plus 1 squared minus 8. So when we're solving for the quadratics, we know y would have to be equal to 0. So now we're solving for x, because we're solving for the roots, and when y is 0. So we solve for x, we add 8 to both sides, and we get 8 equals 2 times x plus 1 squared. And then we're going to divide by 2. So we get 4 equals x plus 1 squared. We're still solving for x. We're going to take the square root of both sides. So this is plus or minus 4 equals, or plus or minus 2. The square root of 4 could be 2 or negative 2. Equals x plus 1. And so x is going to be equal to negative 1 plus or minus 2. So that would be equal to negative 3 and 1. So those are the roots. And then we're going to be plugging those into our equation now. So if x is equal to 1, that factor is going to be x minus 1. If x is equal to negative 3, that factor is going to be equal to positive 3. X plus 3 equals 0. So those are our two factors, our roots. We found our roots, and there is our equation. Okay, for our second problem, it's a little more lengthy, but if you look at our diagram here, it's just as easy as the last problem. Our diagram has our quadratic function. We can see our vertex here. And our x-intercepts we're told are -4 and 6, and our y-intercept is 0, 2, 40. So our first part is just realizing that they're giving us the x-intercept. So our p and q we can just plug in. So our f of x is equal to -10 x minus a -4, so x plus 4, and x minus our q, so x minus 6. So that's our first problem, part A. Okay, for part B, we can see that they want us to put it into vertex form. So a couple different ways to do this. Again, you can try to find the maximum, and depending if it's on a calculator 1 or calculator 2 exam, paper 1 or paper 2 exam, or we might have to complete the square if it's on a paper 1 no calculator. So you here we know our roots, we know our equation, but we have to put it into vertex form. So the easiest way is probably completing the square. And so go ahead and try part B, and then check back with me. Okay, so for part B, if you're going to use the completing the square, you'd multiply x plus 4 times x minus 6 and get x squared minus 2x minus 24. And then you can divide out the factor of -10 for your x squared and minus 2x. And then here I went ahead and multiplied -24 times -10, and so that would be a positive 240. So I left the -10 factor out for x squared and -2x, but went ahead and multiplied it through for 240. Then I'm completing the square for this section. So b divided by 2 is -1. -1 squared is 1. So we're going to have to add 1 inside here, which is really adding on -10 to my problem. So I have to add 10 on the outside because I can't change the problem. So I'm inside here, I'm adding -10, and then I have to so I'll have to add a positive 10, and that would result in -10 times x minus 1 squared plus 250. For part C and part D, you can see how these problems can add up. Here now we're just got to show that f of x is written in this form, so then you got to multiply it all out and get it into this form, and it's not even in standard form, but you would just multiply this through and show that it would equal this. For part D here, then they bring in calculus, so pretty interesting problems that you'll see on the IB exam. But tonight's topic, I just wanted you to realize that you can do the vertex form. It's been a little while since you did Algebra 2, but you can use that using your knowledge of parabolas and symmetry, using the axis of symmetry, or you can use completing the square to put it into vertex form. Thanks so much for listening. If you have want to practice more, there's a chapter 8 you can do completing the square on page 160. Some more problems for that. Have a good night.